All right, so now we can answer lots more questions from our free response notebook. Here's one. We have a graph that describes the velocity of a car traveling along a straight road. We have been asked to find the integral from 0 to 24 of v of t dt. Now this we could have done before, right? So the velocity happens to always be positive. So the integral from 0 to 24 is just the area under this curve. This is a trapezoid, so I find the area of a trapezoid by averaging the parallel sides. So up here, this top piece goes from 4 to 16, that's a distance of 12, plus this distance across the bottom is 24. I'm averaging those and multiplying by the distance in the other dimension, in which case this is 20. So that's 12 plus 24 is 36 times 10 is 360. And then I've been asked to explain the meaning. So I'll type it out here. So I've written that the integral from 0 to 24 of v of t is the distance in meters that the car traveled over the time interval, that should say interval, 0 to 24 seconds. So notice when you're asked to explain the meaning of an integral or derivative, there are two places you have to give units. So what does the area of the velocity curve measure? Is distance. In this case, the units on distance is meters. And we have to give units on the input variable, which is seconds. You also need to state two quantities. Here, the output quantity, the one we were practicing finding, is distance. And the input quantity is time. So you'd have to expect to give units in two places and make sure you state these quantities, the input and the output quantities for the function. This one, you probably knew what it was, so it might not occur to you to state the time interval, 0 to 24 seconds. So notice in this one case, any of those three phrases could be correct, would get full credit. Area under velocity curve is displacement. So you could say the displacement of the car. Notice the phrasing, it's the displacement of the car. You could have said it's the distance traveled, because here velocity is only positive, so it's not unclear if you just say the distance traveled. So the distance the car traveled is also correct. And the third option, you could say in this case, because it happens to be equivalent, that that integral is equal to the total distance traveled by the car, but that's only true because velocity happens to be positive. Just notice the three different wordings, the three different kinds of prepositions that you have to use if you're going to use whichever one of those three terms. We'll see some more examples later on where it does matter which of those phrases we pick. So for this problem, we have a velocity curve for a particle that's moving along the x-axis. And so we have the function, the velocity function's been given to us. That's nice. This is a calculator active problem. Question A, they've asked us to find the total distance traveled by the particle from time t equals 0 to time t equals 3. Well, total distance traveled is the integral over the appropriate time interval, so from 0 to 3 of the absolute value of v of t dt. You can plug this into your calculator. There's an absolute value function on the same menu where you find the numerical integration function, and we get the answer which I've computed here, which is 1.702. So for 1 point you would write this integral, and for a second point you would plug it in your calculator and evaluate it correctly. Now here we go, part B. This is where it all comes together. Find the position of the particle at time t equals 3. And we know that at time t equals 0, the particle is at position 5. This is the most important example from chapter 5. So position, x as a function of t, is going to equal the initial position, which is 5, plus the integral from 0 to t of v of, pick your favorite variable, w, dw. And we've been asked to find the position of the particle at time 3. That would be x of 3. which is 5 plus the integral from 0 to 3 of v of, and here any variable is fine, v of t dt. You could have said v of w dw. And we'll get that answer here. You can plug this into your calculator because, again, this is a calculator section. This was probably 1 point for writing that, and 1 point for evaluating your calculator. So the particle is at 5.773 or 5.774 if you round.